Hello students, let's look at two-dimensional arrays, which are a bit trickier. So the easiest way to think of what a two-dimensional array is just think of a table. So let's say we've got quarterly sales for 3 branches of a shop. It could be a shop selling wine, for example, right? And we've got our column here, second column, third column, fourth column, and the first column is going to be at 0. The first row is at index 0, but we've got a table just like anything else. Okay, so all of these numbers could relate to, on the left hand side, the rows could be different shops, 3 different shops, and the columns represent the times of the year. Okay, so obviously July, September for shop 2 had the most sales. How would we represent something like that in Python? Well, you can store all of this by initializing a variable. Just create a variable equals, and we'll create a list, but we're going to create lists within lists, and each row is going to be stored as its own list. So row 1, which represents shop 1, is its own list inside our master sort of big list. And then I'm going to have 167, 206, 387, 14, and I'm going to have 22, 61. So it's far easier to represent what we're seeing in Python as a two-dimensional table that you might see in Excel or Word if you're inserted a table. And we've got each list inside here as the rows. So that's the best way of visualizing it. And how do we access that 387, the biggest number there? Well, we could do it by using indexing. So I'm going to print out sales, and I need to find which row it's in. It's the second row. So if I just add a comment here, this is at index 0, this list is at index 1, and this list is at index 2. So the list I need is at position 1. So I'm going to isolate that first, and then I can drill down inside. So if I just make another comment, each item here, that's a position 3, 4, oh sorry, what am I doing? 0, 1, 2, I'm fighting with the iPad, that's why, sorry. Just trying to show you how these are all indexed. Tab is a bit better, right? The fonts should be mono-spaced anyway, but sometimes they don't quite line up. So if I wanted to isolate 387, I need to go to the list at position 1, and then the third item along is at position 2. So if I print that out, if I just clear the screen, it should give me 387. There it is. So that's how I can isolate that number. What was the lowest number? 14. Well, that's 14 is in 2, 3. There it is, 14. So that's a two-dimensional array. And we can use these to represent table data. It's the best analogy for it, really. Let's look at another sort of more practical exam style scenario. So the prompt might be write a program to ask a user to enter their name and 5 race times. 3 competitors. Display average time for each competitor. Right, so how are we going to approach this? I'm going to initialize a variable called name, or names should we say, equals, and I'm going to create a list, and I'm going to initialize a list, and I'm going to just make them empty strings because I don't know what their names are, but I know that whatever's going to be in there is going to be a string. So I'm just going to create 3 empty strings in my array, which I can update later. So that's sort of my placeholder. Total time. So in order to find averages, we need the total and divide by the number. That is going to be, we're going to create just a whole bunch of zeros that will update when we know what the numbers are. So we're just initializing some variables first. Average time equals 0, 0, 0. Same thing. Now this is where our 2D array comes in. Race time equals. And what I want to do is write this in a way that's going to be quite clear. So I'm just going to put the square brackets down a bit, put these over here, and I've got 5 times to put in, which I don't know yet. So I'm going to put 5 zeros, comma, and this Python allows me to do this, comma. So writing it out like this really helps us understand what this data structure is trying to represent, like a little table, essentially. Got 3 rows, and each column will be the race times for the 5 race times for each user, which will update when we know what they are. So we've initialized our variables and data structures. Now let's use an iterator to go for each of them and update them. So I would say for competitor, so say C, in range of 3, that will do 0, 1, and 2, which is what we need. We need to target index 0, index 1, and index 2, and then stop, do something 3 times because 3 people. What we'll say is name the at index C, because C will take on 0 when the loop goes around first of all, then it will take on 1, then it will take on 2 and stop. So names at index 0, which currently is just an empty string, we're going to equal input, type in your name here. Type in, let's say, type in competitor's name, and notice that Python tried to give me an extra single quote. I should be able to get away with this because I've got them using double quotes, but you can use escape characters, which we won't get sidetracked too much with escape characters right now, but you can put in quotation marks into an English sentence, and you can have certain characters as being escaped that won't mess up your syntax. Then let's have another loop in here. Once we put our name in, for race in range of 5, because we've got 5 different items which have times we need to put in. We want to update our race times. Okay, so race time at index well, at C, because we want to check we want to use that outer for loops C variable first and go through all of the zeros before we do anything else. So race time at index C and then at index race, and they'll both be 0 at the beginning. 0, 0 will be targeting that first 0 on the left. And equals floating decimal point for a decimal place. Input, because it's going to be a time. Enter race time. Okay, so C will stay as 0, but race will update from 0, 1, 2, 3, and 4, and then stop. So that's how we traverse the first row of our data structure using that loop. So a nested for loop is used to traverse a 2D array. And let's say total time at index C, which starts off as 0, equals total time plus race time, and the race time at index C and race, which will be 0, 0 to start with. So we're going to be updating the total time with whatever that value is pointing to at that particular time. And once we've gone through that for loop, we're done with that second for loop, we're going to say average time at position C for that one user, that first user at C, this one, which is 0, we'll calculate their average time because we're still within the outer for loop. We'll round total time index C, and we'll divide by 5 because it's the amount of things, and in the round function we've got a second parameter for decimal places, which will be 2 decimal places, and we can print that out. Print average race time for, and then we want to have name at index C, which would be starting off as 0, the very first user, the very first of these rows, and then it will go to 1, then it will go to 2, and then stop. Average time, and that will be C as well. Hopefully this is going to work. So I'll just comment out this. We need all of this. Right, type in the competitor's name, James, enter a race time, 32.4. Okay, can only concatenate list, not float to list. Let's have a look at what's going on here then. Let's just try again. Name Enter a race. I'm going to try an integer to start with. I can only concatenate this and not float. So race time. I've got a problem here. I didn't put the SN. So let's try this. Oh, still got an issue. Alright. So fix that issue. For C, so we've got names. I've got my empty strings, that's fine. I've got total time, 3 integers, average time, 3 integers, race time. 2D array looks okay to me. Name C equals input, type in the competitor's name, right, so that's fine. For race in range of 5, race time, C race, which should isolate that very first one, equals float input into race time. Total time C equal that's the issue. So I just missed the C there, the index C equals essentially the whole list plus race time, so it wasn't allowing me to concatenate those together, right? Sorry about that. Okay, so enter the competitor's name, James. Enter race time, 12.2. That's fine. So we're going to do 3 race times. Pretty different race times, but anyway, it's just an exercise. They're all floats. Average race time, 20.82. All right, so then we on to the next row, because we put, so we'll say, what was Olivia's times? So we've got 5 race times. Then she started getting really quick, super quick, slowed down a little bit. So she beat me, and finally, let's put some more in there. She started off really quick, it's quicker than anyone else, but then trailed off because she peaked too soon. And she just lost a lot of energy towards the end. And of the last one, she could hardly do. Okay, but she still ended up winning. There you go. So, what we had there is a quite complicated program, really, for GCSE, but we've got our names as an array. We've got empty strings that we're going to fill in later. Total times that we don't know yet, average times we don't know yet, and 2D array that we're going to fill in the different times for each of the users. So if this was in a table, it would look just like you can see here, where you've got time. If I put the comment in, it'd be something like T1, T2, T3, etc., T4, T5, and on over here it would be contour 1, yeah, and 2. Oops. Competitor 3. So it would look like a 2D table, and we've got an outer for loop, which C will take on 0 at the beginning, so it'd be like C will equal 0, and that will target this one, which is at position 0. And then inside, we're going to be looking at the race time 0 row 0 sort of item in it, because race will become will be 0. So that's looking at the very first 0. We update it because they enter it in, then this loop goes round, this inner loop goes round again, race will become 1, so it looks at the next item, then race becomes 2, but C is always 0 at this point, and then it's 0 4, and then finally this inner loop has done its thing, and all that time we're adding them to our total times for that user, for that one user, so up here, and the average time is then being calculated by dividing by 5 into 2 decimal points. Good. Okay, sorry that a bit long-winded and I had to fix an error in it, but we got there.